Thank you. I'm really excited to share with you folks today some work I've been doing over the last essentially 3 or 4 years at the Science and Justice Research Center and also at the Muonde Trust. I feel like a lot of folks here are talking right now about the sort of issues, right? The need for responsible data science. They're saying some great things about it. I'm just going to kind of touch on that and then talk about some things I am trying to do, like in the work I'm doing with the folks in Zimbabwe, to, at least in that case, do what I think is responsible data science or data science for social good. So just touching on, I feel like there are major issues with the way that data science is practiced. Just as an example, the idea of we're always sort of pushing for more automated things and more automated methods, and there's problems with that. You end up with these, you see articles about like facial recognition, doesn't recognize black faces as human, or doesn't recognize women, or, not even asking the question of whether you want your face recognized in the first place, but, like this, I was actually looking for an article that was from like 2 or 3 years ago to put this in the slide, and I'm like, it's still happening. This is just from last year, and it's not been improving. And people are writing these really wonderful and terrible books about what's going on and what's the problems that we have. And this is sort of aimed at algorithmic things that are influencing people in these kind of broad swaths. And that isn't like the work that I've been able to do, but it's something I'm really interested in talking with folks about in this context of computer science and engineering. So some of the inspiration that I've had for what to do about this problem comes from a lot of folks that I've interacted with and read the work of while I've been at Science and Justice. So I just want to kind of touch on some of those ideas, the things that I'm thinking with. So Donna Haraway, who is a fantastic person and an incredible scholar, has this concept of situated knowledge. And the idea here is that knowledge is partial, it's located, it can't be totally abstract, it can't be seeing from nowhere, you can't really be fully objective because you're always coming from someplace. And the idea is that that knowledge should be accountable to what it's finding, what it's creating, and it's not innocent. And I like non-innocent as a word for that. Karen Broad works with essentially quantum mechanics. She studied quantum mechanics, and this idea of agential realism is the idea that when you observe something, you change it, which is sort of a fundamental quantum mechanics principle. But it's true in a lot of other ways, and a lot of other studies too. And so the idea is that if you want to describe what you're observing, you're actually observing not just a thing, but the way you're observing it is a part of that apparatus. The apparatus needs to be described, right? And that's because people are thinking about waves and particles when you're talking about electrons, but when you're looking at a student in a classroom, the way you look at them may change what you see. Ted Porter from History of Science talks about, there's this crisis of reproducibility. Oh my God, science is not working. But when you look at the methods section of a paper, you don't really get enough detail to try to redo something that somebody has done. And so, you really can't just reproduce it that easily. Miranda Fricker talks about epistemic injustice, which is the idea that prejudices, biases, can cause some people's knowledge to have greater or lesser credibility than others, and that's something we need to be aware of when we're trying to make knowledge, when we're trying to understand the world and the people in it. And then Karis Thompson talks about good science being science with ethics. So you do the ethics while you're doing the science, not afterwards. You don't go figure out, whoops, we did that wrong. You think about it as you're creating it. So these are some of the ideas that I've sort of assembled into an idea about how to do sort of situated data science or situated modeling. And I have a more complex argument that I can't get into in 10 minutes. So I'm just going to give you the high level sort of 3 categories or principles that I thought of. And then I have some specific practices that I could tell you about in more detail offline. One of the ideas is that you really need to, and this is totally what Angus was talking about, contextualizing, right? Giving the context to the way that you created the knowledge that you created, whether you're modeling or you're doing something more, or data visualizing for that matter. And my current idea for that is to maybe write a data biography where you describe how you did what you did, more so than you would do in a methods section in a paper where you just don't have the space for that kind of thing. And there's some other practices that go with that. And then the next principle is this idea of collaborating or triangulating between different kinds of knowledge or different groups, different ways of knowing. And interdisciplinarity is another point that shows up there. And then there's this idea of engaging directly with the justice implications and the ethical issues in your modeling. And that's actually, I think, the thing I feel like I maybe did the best on the example I'm about to give you. So let me tell you about the work that I've been doing with the Muonde Trust. And these are all my wonderful collaborators on this project, so you can sort of quickly skim the names. And this is a photo from Mazvihwa Communal Area in Zimbabwe where these folks work. And this is the Muonde Trust. They're just a fantastic group of people. It's about 30 folks in a community-based research team. And their main aim is to develop indigenous innovations to improve human and ecological well-being. And this is an example. This is a water harvesting structure meant to prevent erosion and from runoff from a lot of really kind of inconsistent rain events. And they've been doing this collaboration for 35 years, working with their community-based research team and with visiting mentors like myself, who are teaching skills that they're asking for. So they're driving that. And then there's been an accumulation of data over that 35 years on a variety of different projects and a variety of different levels of quantification. And that is the archive, as you can see, in paper form. And so we wrote a grant to try to study the resilience of their agro-ecosystem using this data set. So I'll tell you a little bit about the questions, and the questions again came from the community. So that's a community-based sort of origin for the project. They're interested in land use planning, which seems like a fairly simple question, but we all struggle with it in the United States as well. And they're trying to figure out how much land should we allocate to crops or to arable uses, and how do we arrange it? Do we clump it all together, or do we scatter it throughout the area? What are the impacts of Muonde's projects, like those water harvesting structures or stone walls? And then I sort of threw into the mix also, so that this is less community driven, but they're all very interested in how climate change is going to impact them. They're very aware of what's going on. And so they agreed with me on that one, even though that was technically my idea. How do we put greater variation in rainfall due to climate change into this system? So then I was at the Santa Fe Institute for their Complex Systems Summer School in June 2015. And we had to do a final project. And so what we decided is we were going to model this agro-pastoral system using an agent-based model, which is a simulation-based model in NetLogo, which is not the most ideal programming language you've ever met, but was good for this purpose. So, and there's a shot of the model running, and it has questions, and then some graphs that come out, and you watch the little cows run around. It's actually kind of fun to watch. But the model was based on these underlying rules for the agents and for the patches and the parameter values that came from the community's input and from that data, from that 35-year data set. And so we were really able to kind of put a lot of sort of realism, to the point you can do a realism with agent-based models into the system. And then what we did is we did workshops to explain and play with the model and discuss the management of the real system with the folks in the field. So we did these sort of small group workshops where we sort of had people actually physically trying to change the sliders and make the cows do different things and see what happened. And we did that in a few small groups, and we have folks taking notes on what people were thinking and saying about it, or maybe thinking what they were saying about it. And then we did these large, the whole group came together and we talked about the system and we talked about what they thought about the model. Some quick reflections on creating the model. So the collaborators who hung out at SFI are from all over the world. They're interested in the tools and or the topic, but working with the community was a meaningful motivator. So I did hear that from multiple people. And then we had some collaborators who knew the system and could compare with on-the-ground behaviors. And then the awareness of the actual modeling process changed for some of those folks who are sort of more on the quantitative side or the programming side. From the community, they decided that the model was generally good. They said it is not a liar. It means that they remember, they're watching the rainfall, and they can see, when I use the historical values, yes, I remember that drought, and what actually happened in the real system. The cows really do things like that. Enough of those management strategies that they employ in real life were present, so the model was sort of recognizable or meaningful to them. And they did think of uses for the model, and it did generate some great discussion. And what they were able to do, both through some other projects we're doing with mapping, community-based mapping, and these modeling workshops, Muonde is now helping to develop a biocultural restoration protocol for Rambotemwa, their sacred forests. And they've been able to talk with local leaders, and that is one of them in front of the computer there, who are now talking about recultivating fallow fields rather than cultivating the woodlands. So they're being able to preserve some more of the woodlands. So just a quick idea of, so how did we do here? We're now writing, to do the data biography, we're writing 2 different papers, one about the model results and one about how we did the process, how the technological and social infrastructures mutually supported each other. The modeling process really it began from their questions, used their data, proceeded with their input, and I think that's why instead of having unintended negative consequences, we have intended positive consequences, which is really great. And the conclusions are, I think we need more, just, more collaborative, more critical modeling and data science. It worked well here because of that deep, sustained community involvement. And I want to know, how do we do that in situations where you can't just you don't have this 35-year, research project with these really fantastic, local researchers and this opportunity to really make sure you're addressing their questions. How do we bring that to facial recognition or, something that's really very broad and affects lots of people? And, there's that sort of algorithmic justice problem. And then others are thinking about this. And in fact, apparently quite a few of us are here today thinking about this. So how do we come together and do this, make this really change at a basic level? And I think this is a great start. So, thank you. Sorry. Thank you.